All right, so in this chapter, we are going to be talking about mainly area of different shapes. And I'm going to start with the two most basic shapes that we are going to work with. And every other area formula we talk about after today is based off of these two shapes. So, to start, the area of a rectangle, you might know it as length times width, but I'm going to use the vocabulary of base times height. And the reason I use base times height is because if I stand this rectangle on one of its sides, the base and the height are perpendicular to each other. So the concept of base and height are going to be important for understanding the area of different four-sided shapes. So that translates to the area of a parallelogram. So a parallelogram does not have sides that are perpendicular, so the height of a parallelogram is not necessarily a side. It is a distance from one side to the other, and it's perpendicular to both of those sides. So the base of a parallelogram is going to be perpendicular to the height of the parallelogram. So that's a main thing to remember. So in example 1, we're going to use these formulas to find the areas of just parallelograms right now. So in part A of example 1, the base of this parallelogram would be 5, and the height corresponding to that base will be 4. So simply the area is base times height. 5 times 4 is 20. So this has an area of 20 square inches. For part B, the base would be 2 centimeters, and the height for that base would be 3.5 centimeters since they are perpendicular. So the area of that parallelogram is going to be the base 2 times the height 3.5, which is 7 square centimeters. And it's important that we remember area, the units for area, are units squared. So in the next example, we're going to talk about using the area, or finding the area and using it to find a missing dimension of a shape. So when we look at this shape, the way it's standing right now, we're trying to find the length of DE. And what DE is in this parallelogram, I would consider this a height. And it's the height that corresponds with a base of 9.4. Now, if I look at this parallelogram a different way, so I'm just going to put that off to the side. If I look at this parallelogram a different way, 13 could be a base, 9 could be a height, all right? So I'm going to find this area of this parallelogram using 13 as a base and using 9 as a height. So I just have to do 13 times 9. So 13 times 9 is 117 square inches. And the reason this helps me solve this problem to find the height is that the area formula is base times height. So in this formula, I know the area of the parallelogram, I know the length of a base, I need to find the length of the height. So the area I know is 117, so I substitute 117 for A. I know the base that we found in the beginning was 9.4. I don't know the height according to a base of 9.4. So I substitute 9.4 for the base, 117 for the area, and to solve this, I just have to do 117 divided by 9.4. And I'm going to have to round this. So I'm going to round it to the nearest tenth, since that's what the directions say, 12.4. And this is not inches squared because this is a height. This is a measurement, a one-dimensional measurement. So that's why it's just 12.4, not 12.4 or 12.4 inches, not 12.4 inches squared. It's just a one-dimensional length, not an area. So using the formula is helpful there. On the back, I would like you to just try these two guided practice. So take a few seconds to pause the video, work through each of them, see if you can solve them, and then when you're ready to move on, check your answers, and then we'll just cover the area of a triangle after this. Okay, so for these two, one is a little more straightforward than two. Number one, you just do the base times the height. base of 12, height of 9. 12 times 9 is 108 meters squared. Number 2 is a little more challenging. In number 2, we look at is we know a base and a height that correspond to each other. 9 and 15 are a base and a height that correspond to each other. We know a different base could be 18, but we don't know the height that corresponds to a base of 18. So we use the 9 times 15 to find the area, and then we use that area formula to do the area divided by that base to get the missing height. So that's why the height is 7.5 for a base of 18. And you can go back and you can test. You can do 18 times 7.5. It should be 135. So the last formula is one hopefully you're familiar with, the area of a triangle. And the area of a triangle is pretty simple. It's 1/2 times the base times the height, or the base times the height divided by 2. So again, same vocabulary of base and height. Remember, base and height are perpendicular to each other. So the height doesn't necessarily need to be a side of the triangle. It's just a height that is perpendicular to a side, okay? A height that is perpendicular to a side. So in example 3, finding the area of this triangle, we have to be careful because if you notice, the base and the height are not in the same units. So what I would say is the base of this triangle is 12 inches, the height is 5 inches. So what I did was I converted that 1 foot to 12 inches. Area of a triangle is a pretty basic formula. 1/2 times 12 times 5. If I do this in order, 1/2 times 12 is 6. 6 times 5 is 30. So this has an area of 30 square inches. And that's it. In example 4, this is just combining both of our area formulas. So all we do is take the area of the triangle and we add it to the area of the square at the bottom to find the area of the whole figure. So it's understanding that for the area of the triangle, that's going to be 1/2 times, and I know the base isn't written there, but these markings mean that this is a square, so the base is 6, the height is 8. 1/2 times 6 times 8, 1/2 times 6 is 3, 3 times 8 is 24. That has an area of 24 square inches. The area of the square, base is still 6, height is 6, 6 times 6, 36 square inches. So the area of the total shape, the total area of the shape, 24 plus 36, which is 60 square inches. So just understanding that if we have a shape that's made up of multiple shapes, we find the area of each smaller shape by breaking it down into smaller shapes, and then we add those areas together. So you should be ready for a little bit of practice. Remember, these are 2 formulas that are going to be common enough that you're not going to be allowed to use a sheet for these 2 formulas because they're both pretty basic. Later on, when we cover more uncommon formulas, you're going to need a sheet to help you with those. But that I'll explain that later.